I'm here with Ramya Origanti. She's a program manager on an engineering team, and she's going to talk to us about what's new with Azure Functions on Container Apps. Super important pair of technologies if you're building for the cloud. And Ramya, thank you. Introduce yourself and tell us what you've been working on.
Yeah, thanks, Matt. Thanks for having me on your show. I'm super excited to talk about some cool new stuff that's happening on the function side. So my focus areas are enabling functions on Kubernetes-based environments, and as part of that, we've launched functions on container apps where users will be able to run their function apps as containers on a managed Kubernetes environment, such as Azure Container Apps. So we've launched this service in preview last year in May during the Build conference, and a whole set of features and enhancements that we've brought into the service. So I'm super excited once again to kind of share all that we've got for the customers, and also I'm going to show a demo as well. Yeah, we're going to see things in action.
Awesome. Running functions in a managed Kubernetes environment, that sounds hard. Have we made it easier? Not anymore. Excellent. Tell us.
Yeah. So before I talk about the Kubernetes ecosystem and the managed environment, so Azure as such has a rich set of services for building these cloud native applications. Because when you're talking about containers and microservices, these are all cloud native applications, right? So these apps and then we often think about Kubernetes. And in Azure, we have services like Azure Kubernetes Service to support, and host these cloud native apps as containers on AKS. But as developers, we prefer to work on higher abstraction, right? Like Azure has services like Azure Container Apps, Azure Functions that will allow us to focus on code and not to worry about the underlying infrastructure. And of course, apart from this, customers can take the full advantage of the application stack and the entire Azure ecosystem, including databases, and a lot new AI capabilities as well that you've been hearing about these days.
Yeah. Super helpful. Thank you. So what is Azure Functions?
Yes. So Azure Functions is a serverless solution, right? Like which offers an event-driven compute experience, and it allows customers to write code in the language of their choice. So with Azure Functions, users will be able to connect to other services without hard coding the integrations, and it also enables faster development because of these extensions that Functions has. It enables customers to write triggers and bindings seamlessly and connect to the services of their choice smoothly, right? Because of the programming model and the extensions that come with Azure Functions. It also offers an end-to-end inner loop and outer loop dev experience where users can have build their function apps locally. They could debug it, build it, and deploy them onto Azure and monitor them as well.
Nice.
And it supports on all the major platforms, right? Like Linux, Windows, and Mac OS as well. And the other cool part about functions is that you build once and you can deploy it onto multiple destinations, right? Like on managed service on Azure, or you could use one of the hosting plans like consumption plan, elastic premium plan, or app service plan. Or customers can also deploy their function apps as containers on AKS or Kubernetes hosted environments. And this Kubernetes environments could be on Azure or on any other public cloud. Or they could also run on IoT devices or edge compute using these open source function host and runtime images that are available. So these images can be like containerized and run as containers on Kubernetes environments hosted on any cloud or IoT edge devices as such.
So a lot of flexibility. Yeah.
Yeah. And apart from that, functions can scale on demand. So functions are triggered when it's all event based and event driven, right? So when there are events, functions execute and they can scale on demand. And customers get to pay only for the time. They can pay only for the time that the code is executed. So if, as you can see, right, so it's like users are able to focus on code and not really worry about maintaining this infrastructure. There are several, they can optimize on their usage of infrastructure and need not really worry about, maintaining servers or, how to kind of keep these applications up and running.
Yeah, I don't want to worry about networking.
Users have an option to deploy their apps onto a public VNet or a private VNet. And it's just like there are controls and configs available to let the service know which type of network the customers need to deploy their functions on. It's
Great.
very minimal and abstracted.
Nice, nice.
So we have launched the public preview release of event-driven serverless Azure Functions for microservices last year in May. This is a new hosting option that will enable developers to quickly build event-driven cloud-native function apps and also have that flexibility to run functions with other microservices, APIs, websites, workflows, or any container-hosted programs. So it supports Azure Functions integrated programming model, right? You could, like, customers can choose any of the extension of their choice, develop triggers or bindings. They can pick the language of their choice and integrate with other APIs or apps of different programming languages. So they could have like a JavaScript front-end app running as a container app and a function app written in .NET running as a container app. So like this, the front-end JavaScript can talk to the .NET container as such. So you can have these mix and match of containers running in a unified container app environment.
Nice.
And with different types of apps, there's a lot. There comes the management of DevOps, right? And the promise of true cloud native experience is about managing with DevOps processes and tools. And this is already supported by Azure Functions, right? And you can use the same tools and management to that you're already familiar to deploy functions. Like customers can deploy functions on container apps using GitHub Actions or Azure DevOps pipelines.
Nice.
And users can also integrate with multiple app types, like I just mentioned, like a web app could be on a container running a JavaScript web app and a function and an event source, right? And all of them can be hosted in containers. Users will be able to integrate, build, and deploy all of them together using ARM templates or Bicep templates. Like you have like one infrastructure as a code, a template that you could build, and various resources can be resource deployments can be defined in this. In an ARM template or a Bicep template and in executed. So all of the target resources will be created in this container app environment. And apart from this, users can also leverage technology like Dapper. So Dapper helps to weave those apps together, those microservices. It'll enable users to build that resilient, secure systems. And Dapper is built on this, it has this best practices it provides this best practices for distributed application development with the resiliency and the retry and then the number of bindings that Dapper provides as such. And finally, like no infrastructure management whatsoever. So
nice.
So yeah, it's all like if you just focus on your code and you deploy it.
Yeah.
And also from the networking that, like you just mentioned, Matt, hey, I need not worry about network. So all of this, like in a container app environment that these container apps would be running. So the networking can be managed and configured at an environment level. So you configure once and deploy all the apps into this particular container app environment. And these network settings are applied to all of this. So you need not individually configure. And same is the case with observability as well. So you define the target observability service that you want to stream all your logs, and all these apps running in the container apps environment would be streaming their logs into one unified observability service.
Makes it easier for everyone, the whole team.
Yeah, absolutely. So like it can go in a self-serve mode, like developers can themselves like pick the observability service and configure it so that all their apps are kind of using one observability service, and they get this unified single pane of pane window clearance of all the apps and their performances and the logs that they can monitor.
Great.
And finally, this environment supports scaling as well, right? Like function apps can scale all the way to 0 and they can become inactive, or they can scale to dozens of containers under high load. So there are, and this is how possible using KEDA. So KEDA is that component. It's an open source tech. It's optimized to run on Kubernetes-based environments. And here in container apps, it's seamlessly integrated where customers need not even configure the scaled objects like they do in AKS or Kubernetes. So there is the service is managed in such a way that it detects the type of function app and configures the respective scaled object, which helps to scale these function apps based on the load.
Kubernetes event-driven architecture.
Yes, that's right. Kubernetes event-driven autoscaler.
Autoscaler. Okay, thank you.
Yeah.
Keda.
Yeah. So I want to touch upon some of the use cases and the target personas for this particular service, and this is based on the various customer interactions that we've had. So we've seen and learned that cloud native developers, backend developers, and data scientists could benefit from this offering because they often deploy mixed workloads, like their architectures, the microservices architectures would have function apps and other APIs that are, uh, that are hosted and running together. And specifically for functions in container apps, like we've seen users use this for HTTP triggers, Kafka, event hubs, or service bus. And these particular function apps can invoke another API or web app, which is running in a same container app environment, and also scale on demand based on the events, right? And all of this is possible using the Keda that I just spoke about, and the triggers, the extensions, which has these triggers and bindings bundled, and offering the choice of language that user wants to build their function apps on. Right. And we've also seen customers use event-based data ingestion platforms, right, to perform those quality checks, the data quality checks for online retail or e-commerce or travel apps. So this is predominantly used for validating data for accuracy, completeness. So whenever data is kind of coming into these shopping carts or travel apps, uh, or order processing components, the function apps gets triggered and it performs these you know the data, the checks, and for accuracy and completeness. And based on this, it can also it's capable of invoking other ML workflows, right? Like once the data cleansing operations are completed, so this data can be like channeled into a system where the machine learning processes are running, and function could be used in such a scenario to kind of streamline all these data, the cleansed data into such systems. And finally, IoT is also another use case scenario where functions can be used, like smart devices or IoT, which continuously sends telemetry, and it needs to be routed to other units for processing where these events land in, event hubs or Kafka topics, and functions pick them up for processing and transfer to the downstream systems. So these are the various personas and some examples where like customers could experience those mixed workload kind of applications, and they could run their function apps and other APIs as containers and container apps environments. So like I mentioned at the beginning, there's several enhancements that we've been doing to functions on container apps, and you'll be hearing more, and we're about to GA launch the service as well. But before that, we're excited to announce the following features, which is the platform managed scaling support for timer trigger in Azure Functions for container apps. So this will allow customers to run a function on a particular schedule and and it enables function apps to scale to 0. And when the schedule occurs, it scales to 1, executes it, and scales back to 0. So this eliminates the need for customers to configure those Keda scalers or minimum replicas. So there's this new timer Keda scaler that's been written or released, which helps with this scaling of the timer triggers. We've also launched the workload profile and environment support. So these profiles support apps and consumption and dedicated plans across these workload profiles, and they work in a unified container app environment as such. So it specifically gives customers the option to run function apps on dedicated or GPU compute resources. And so the dedicated compute has a range of CPU and memory compute sizes that customers can choose. Apart from this, we've also released a Dapper extension for Azure Functions and the seamless integration with Azure Functions on Container Apps. So customers can actually build functions that react to events that are coming from Dapper or external systems, right? So, so this Dapper extension helps that integrations between functions and other microservices or APIs that are hosted in this container app environment. And through this extension capabilities, use cases such as service discoverability, pub sub, and bindings are possible. And due to this control plane integration, it gets even more. This accelerates the time to deploy a Dapper extension-based function app on a container apps environment as such, because it is tied to an ARM resource, and you could define all your configs from control plane or from client tooling like Portal or CLI.
Yep.
And finally, we have enabled functions extension to deploy functions on container apps environment. So users can use VS Code and leverage the functions extension to create and deploy function apps on container apps environment. So as you can see, all these efforts accelerates the speed of deployment of functions from code to cloud.
Yeah. This is a rich set of improvements.
Yeah, and there are more coming up, including the GA launch, which I'll talk more about it in a bit. So I think it's time to see things in action.
Yeah,
so,
demo.
Yeah. So I plan to showcase a demo. So it's about how to deploy a timer trigger function app in Azure Container Apps hosting environment. So just to give some context here, so imagine a situation where a process needs to be executed on a schedule to perform tasks such as cleaning up of databases, sending emails, or processing some data at a certain schedule, or generating reports. Or it could even be like performing health checks or monitoring the status of applications or databases. And if such applications need to be deployed in a microservices cloud native environment, right? So for such scenarios, customers can use this timer trigger function app, right? Where this timer trigger function app can be deployed as a container, as a microservice on a container app environment. So let's see how to create such a function app in a container and deploy it to Azure Container Apps environment. So I'm going to share my screen. Hopefully you're able to see my screen.
Yep.
So this is in this example, like you could see, right? It's a simple timer trigger function app. It's written in .NET isolated, and it's a pretty simple one. It's scheduled to execute every 12 minutes, and after successful execution, it logs that it has executed. And logs the schedule as well, and also prints the next schedule. So this app is being containerized, and it's also built and pushed to a Azure Container Registry. And I've used the Azure AZACR build command to build and push this image into this container registry as such. So now let's see how to create a function app in Azure and deploy this containerized image into the function app hosted on Container Apps. So I'm going to head to the Azure portal screen.
Yep. Can you zoom in just a little bit?
Okay. Oops.
Other way, yeah.
Is this better?
That is, thank you. Yeah.
Okay, cool. So here we are in the Azure portal in the Create Function App experience. So I'm going to go ahead and create a function app. And I'm going to show you how to deploy a function app in a container apps environment. So in the Create Function App blade, go ahead and choose a subscription and a resource group. Um, and then provide a function app name and select the deployment mode as container because we're about to create a function in a container. All right, so I'm going to choose it as a container image and then go ahead and pick a region. And then the hosting option, choose Azure Container Apps Environment Plan because this is where we're going to deploy this. And then now we'll go ahead and create a container app environment. Users have an option to choose an existing one or create a new container app environment. But since in this demo, I want to show how to create workload profiles, which comes with both dedicated and consumption plan. So for that, I'm going to quickly show you how to create a workload profile for this function apps. So go ahead and click on create a new environment and make sure the workload profiles are selected. So by default, consumption plan is enabled and users will have an option to choose CPUs up to 4 vCPUs and 8 GB RAM. Apart from this, users can also create a dedicated compute. For that, they're expected to click on add workload profile, which nudges the customer to first provide the workload profile name and then click on choose a size. So this is where users get to choose a dedicated compute. There are a wide range of dedicated compute SKUs that are available. And do note, so GPUs are also supported. So this is the only hosting option where users get to deploy functions on GPU SKUs. So GPUs, as you know, helps to GPU compute specifically is used for processing large images or video processing, or it can also be used for training LLMs or SLMs on demand. And there could be more scenarios as such, but these are the some of them uh, uh, that I just mentioned. So, but for this demo, we'll go ahead and choose the D4 workload profile. So as you can see, the dedicated compute queue that we have chosen has been selected and then click on add. And auto scaling instance, it's recommended to have like 3 to 5, it's the default and also suggested for production workloads. So the workload profile we just created is now here. We'll leave the monitoring and networking as defaults here and can click on create. So you can click on storage. So the next, so the storage can be left to default here as well. And then the monitoring. So this is where monitoring for monitoring app insights has been enabled. And this is where the function logs gets streamlined and users can monitor the logs of their function apps. So it's important that the app insights is turned on. And finally, click on the deployment tab. So here in the deployment tab, if there is no image, you want to try out the service, we have a quick start image. It's a HTTP trigger. But since users also have an option to choose from a public repository or a private repository. So ideally, we could include the timer trigger image that we've just pushed into the ACR here. But since for private, it is needed to add the server URL and the username and the password of the particular registry, right? So, but for this demo, I'll go ahead and click check the public image, right? And uh, let me provide the sample function app, and then finally, this is where user gets to choose, define the configuration of CPU and memory for that specific container app. So the default consumption plan has been seen, and also the workload profile, the dedicated compute has also been seen. So if user wants to choose a dedicated compute, they could choose the compute option that they have just created in the previous step, and also have an option to specifically choose the CPU and memory for that particular container app within the dedicated compute. So this particular dedicated compute can have multiple container apps leveraging those options. And from a consumption standpoint, it have a wide range of profiles here, starting from 0.5 CPU to 1 GB of memory to 4 CPU cores, 8 GB memory. So I'll go ahead and choose a 0.75 CPU cores and 1.5 GB memory there, and then proceed to create this particular resource. So in the interest of time, I have already created a function app, so which is running with this particular timer trigger function app as such. So users have an option to go to the configuration tab. So this is how the screen looks once the function app is created. And then if you go to the configuration tab, users get to see the image that they have given as an input for this function app. And here there is an option for users to also change their CPU and memory cores as well. In case they think that, if the process needs more resources, then they always have an option to update this, or they could use the easy CLI or ARM template as well to update their configs. So now let's head to the live metrics to see things in action. So as you can see here, as the function apps executes as per the schedule, like it's scheduled to execute every 12 minutes. The container app gets started, and it starts from 0, executes the process, and then scales back to 0. And yeah, you could see, like, the time it was executed as well in the traces. So since it's a 12-minute schedule, it takes a while to kind of scale back to 0 and then scale to 1. But hopefully this gave a picture about like how things work. And also do note that I have not configured any scale rules, defined any rules for scaling as such. So it's auto configured, and it works like a charm, right? Like it executes as per the schedule time and then scales back to 0.
Great.
So I'm going to go ahead and go to the presentation now.
Okay.
So hopefully, we have launched the workload profile support and timer trigger in the month of March 2024, and this is hot off the press, the demo. So I really encourage folks who have requirements to run function apps as containers on a particular schedule to try this out and let us know. And also stay tuned. We'll be launching the entire service, the new hosting option in Azure Functions, which is Functions on Container Apps in GA. And we're also introducing capabilities to enable secure access from functions container apps to Azure AD protected resources using managed identities. So the MI support will be out soon, along with the GA launch. And we're also providing the ability to control network access to functions resources by providing the support to VNet internal, which means users will be able to deploy their function apps into a VNet, which is it's a private one and which does not have public access whatsoever.
Yeah. Important for a lot of scenarios. Yeah.
Yeah, absolutely. And most of the enterprises, they prefer to deploy their resources in a private network and do not expose them publicly. So this is like a top ask within our customer base, and we'll be releasing it out soon.
Great.
And finally, you must be wondering when to use functions hosting plans, given that, there's elastic premium plan, consumption plan, dedicated plan, and now functions on container apps. So I would like to touch upon like when to use what, just to give a quick idea about like, hey, what is a suitable plan to deploy my function apps, if that's the question, or if that is something that you're exploring. So consumption plan is one of the plan that function supports today, which is optimized for serverless scale to zero, and also supports event-driven function native workloads as such. So and the flex consumption, which is coming up with all new performance improvements and VNet internal. The private VNet support, it's going to be launched in public preview during the Build conference in 2024. So that'll be out soon. And then functions premium plan, it's ideal for, so all your serverless scale to zero native function apps can go to consumption. And functions premium is ideal for workloads running continuously. And, if you want to have, like, you can't afford to have cold start whatsoever, and you want these functions to continuously run. So premium plan is suitable, and this plan offers event-based scaling as well and network isolation. Apart from this app service environments, it's a fully isolated, dedicated environment, and it's suitable for workloads that need large queues or need to co-locate with web apps and function apps together in an app service environment. Then that's the option. And finally, functions on container apps. If you want to run functions as containers in a microservices environment, then functions on container apps is the hosting option that you could go with. And of course, if you want to run functions alongside with other microservices APIs, then there's the option. So hopefully this has given again a good view of different plans and when to use what.
No, actually, it's a great slide. I mean, it made it pretty clear, and so thank you. That's good. Yeah.
Cool. Yeah, again, we get this question asked a lot from our customers. So thought it'll be good to kind of touch upon this. And finally, so check out the service and features that are available. So let us know what you think. It'll be great to get feedback as well. We have a survey running. If possible, I could share the link, and it'll be great to hear out. And we do have like the docs and the GitHub repos and several samples out there. The timer trigger samples, all the DevOps pipeline samples as such. So do explore them, leverage them. And you could also post your asks in our GitHub repo as well.
Nice. And I'll post all these links in the description on YouTube here. Yeah.
Well, thank you so much, Matt. It was, I hope this gave a good view of all the new enhancements that are happening in this new hosting option in functions.
No, yeah, this was great. And I can see right away a bunch of different scenarios that this is going to enable that are more and more needed as people are doing bigger and bigger things with AI and microservices, and really as we're really all taking advantage of full cloud native and microservices architecture. So thanks a ton for this. Very clear. And hope to have you back on the next time you've got some great improvements like this. Thanks so much.
Thank you so much. Thanks for having me on the show once again.